This video is going to be the continuation of 5 graphing radical functions and inequalities. Now, I want you to try number 6 and 7 on your own. I took my time with the first video. So try to graph them, pause the video, do the domain and range, and then play the video again. Now, let's start with number 6. To graph a radical function, you always start. This is my pre-AP video. So you always start with the parent function. Now, plus 8, it means you have to subtract an 8 from the x. So let's do that. 0, negative 8, then negative 7, negative 4, and 1. There's no other change done to the x, so this is going to be your new x. Now for the y, there's a couple of changes. There's the negative first, so make it a negative. Then you're subtracting a 2. The k is negative 2, so subtract a 2. And this will be my new y. So my new x is negative 8, negative 2, or the first point. The end point is negative 8, negative 2. Then we have negative 7, negative 3. And it does make sense. As you can see, it's going to go down. It's not a shooting star because it's reflected. And 1, negative 5. So it's going to be a reflected one compared to the parent function. So as you can see, it's reflected, it's shifted 8 steps to the left and down 2. So now let's see what my end point is. You can either look at your table, so it's negative 8, negative 2, or you can look at your radical. So you should be able to tell what the end point is. So it's the opposite of h, of this number over here, which is a negative 8, and it's the same as k, which is negative 2. So the end point is going to be hk, just like the vertex in quadratic functions. So the domain is always going to be from the end point, which is the x, which is negative 8 to infinity, and the range is going to be from the k, either up to infinity, if it's going up like a shooting star, or going down to negative infinity if it's not a shooting star. So it's going to be then from negative infinity to the y of the endpoint, which is a negative 2. So let's try the other one. Again, you start with the parent function. 0, 0, 1, 1, 4, 2, 9, 3. And then you add a 3, so opposite. So 3, 4, 7, and 12. This is going to be your new x. And then you subtract the 4 from the y, so it's going to be negative 4, negative 3, negative 2, and then negative 1. So this is going to be your new y. So let's graph that. 3, negative 4, 4, negative 3, 7, negative 2, and then 12, negative 1. So as you can see, it's a shooting star, starting from this point. This is the end point of the square root function. So you were able to find the square root or the end point from the function. So it's the opposite, so 3, and the same, so negative 4. So it's always hk. So 3, negative 4 is your end point. Now the domain is from the x of the end point, so let's see what it is. It's 3 to infinity, always to infinity the domain. And the range is going to be, since it's a shooting star, so it's going to be from negative 4 to infinity. If it's reflected, it would be from negative infinity to the point. Now that is how you graph radical functions. Now how to solve radical equations. This is what this question is about. So what I'm going to do, I'm going to do it on I need more space. So I'm going to do it on I'm going to make this bigger because I need space to write this. So find f of 17. f of 17, it means x is equal to 17. So you plug in 17 for x. So I'm going to write down the equation. Y equals to negative square root of x plus 8 minus 2. So negative square root of 17 plus 8 minus 2. So negative square root of 25 minus 2. Negative square root of 25 is a 5. So it's going to be a negative 7. So f of 17 is equal to negative 7. Now go ahead and try the other one on your own. The f of 5 of number 7. Pause the video and then play it again. So f of 5 is equal to what? It means you have to plug in x equals 5 and find y. So y is equal to square root of x minus 3 minus 4. That is your function. So you plug in a 5 instead of x and copy everything else. Square root of 5 minus 3, so that's a 2 minus 4. So that would be sufficient. You do not have to find what the square root of 2 is since you don't have a calculator. So that would be acceptable. So f of 5 is equal to square root of 2 minus 4. So let's do now the other part, the other question, which is if f of x equals to negative 5, find x. It means y is given to be negative 5. I'm also going to make some more space. So I'm going to write over here. So f of x is equal to negative 5. So this is number 6. So it means that negative square root of x plus 8 minus 2 is equal to negative 5. Now to solve a radical equation, you have to isolate the radical. You get rid of whatever is being added or subtracted first. So let's get rid of this by adding 2 to both sides. So negative square root of x plus 8 is equal to negative 3. Now you divide by a negative because you need to isolate your radical. So what you're going to be left with is square root of x plus 8. So those will become a positive and those will become a positive is equal to 3. Now as you can see, I isolated the radical. Now what you need to do is square root both parts of the equation to get rid of the radicals. So by squaring a square root, the square root is gone. So you are left with x plus 8, and 3 squared is a 9. Subtract 8, so x is equal to 1. So if f of x equals to negative 5, x is equal to 1. Now go ahead, try the other one. F of x equals negative 3, find x for number 7. This is number 7. So go ahead, try, pause the video, do it on your own. Let me make room for myself. So f of x equals negative 3, let's try it. It means that the y, which is square root of x minus 3 minus 4 is equal to negative 3. The y is equal to negative 3 and I have to find x. So isolate the radical by getting rid of negative 4, add 4 to both sides. So square root of x minus 3 is equal to 1. Now how can I get rid of the square root? You square both sides. So the square root and the square, they disappear, so you are left with x minus 3 is equal. 1 square is just a 1. You add 3 to both sides, so x is equal to 1 plus 3, which is a 4. So if f of x is equal to negative 3, x is equal to 4. This is how you solve radical equations. Now, how do we graph radical inequalities? How do we graph radical inequalities? I'm going to do 8 with you, and then you can try 9 on your own. So this is how we graph radical inequalities. First of all, you start just like you graph it just like you would with any other radical equation. So you start with the parent function. Opposite, so you subtract a 2. Nine minus 2 is a 7, and then you add a 5 to the y. So that's going to be my new x, and that's going to be my new y. Now let's graph them. Like this one, so I can be able to look at the table. So as you can see, my end point is going to be -2, 5, and my table shows that too. So -2, 5, -1, 6, 2, 7, and 7, 8. Sorry for the scratch. Okay. So as you can see, it's a shooting star starting with this point. Now, it's y greater. So it has to be greater. It means you have to shade above your graph. Now what you need to do is, whatever your endpoint is, draw a vertical line. So you know where to shade. Draw a vertical line over there. Now, and then you need to shade above your graph. So this is where you need to shade. Now I made a mistake. As you can see, it's y greater, so my line has to be dotted. Keep that in mind. So let's review. If you have a radical inequality, you would graph it like you would graph any other radical equation. Then after you graph it using this method and graphing it, you decide whether you need to shade above or below. If y greater, you shade above. If y smaller, you shade below. Now, above, is it above all the way even up till here? Now, to know where to be shading, whatever your endpoint is, draw a vertical line. So that's your limit. It means when you shade above it, you have to stop wherever you drew the vertical line. And the vertical line has to be going through the endpoint. And this would be shading above. Now let's try to answer those questions graphically. So every time they ask you a question like that, if graphically, you just look whether it belongs to it or not. So I'm gonna put the dots in red. So 0, 0. As you can see, it's not in my shaded part, so it's not a solution. No. Now 3, 8. 3 and 8. So this is 3, 8. As you can see, it's above the graph, and it is in your shaded region, so yes. 2, 7. It's on your graph, and since y greater, so the line is dotted, it's not included. So no, it's on a dotted line, it's on a dotted graph, so it's not included. Now this is how you would answer this question graphically. Now go ahead, do number 9 on your own, pause the video, and then play it again. Now, in order to save time, I did the table and did the graph, so check your work. Now they're saying y is smaller or equal. So at your endpoint, draw a vertical line to know where your limit, where to shade up to. And since it's y smaller, it means you have to shade below, and your graph has to be a solid line, not a dotted line. So you shade below your graph. So think of it as a rainfall whenever it's under the graph. So are these points, I'm going to use the blue, 0, 0. So as you can see, it's not. 6, 1. Since it's on the graph and it's solid, so yes. -4, -5. It's beyond the line, the vertical line, so no. This is how you would solve something like this graphically. Now, let's move on. Which of the following ordered pairs are the solution of the following inequalities? Now this, you have to do it algebraically. Now to do something like this algebraically, it means you have to plug it in and see if it makes sense. So let's try it. I'm going to try the first one over here. So -2 square root of x plus 4. So the x in this case is a -5 plus 4 plus 3 on the outside. So you plug in for x, -5, and you solve it. Whoops, you have a negative under the radical, and that is impossible. So the first one is a no-no. Now let's move on to the other one. I'm going to do, so you can do both of those together since the x is the same. So -2 square root of 0 plus 4 and plus 3. -2 into, or square root of 0 plus 4 is a 4. So -2 square root of 4 is a 2. So that's a negative 4 plus 3, which is a negative 1. Now you found an answer. Now I'm going to do this one first. You plugged in x equals 0 and you got negative 1. Now is the y in here? And they said less. So is the y in here that you got less than the number you just found? So let's see. Is negative 5 less than negative 1? Yes. So that is a yes. 0, negative 5 is part of the solution. Now, is the y in here? Is the y less than the number you got? Is 6? Is 6 less than negative 1? No. So that's a no. Now let's try one more and then you do the last one on your own. So y equals to negative 2 square root of x plus 4 plus 3, and I'm going to check if this is part of the solution. Plug in x equals negative 3 and solve it. Now square root of negative 3 plus 4 is a 1, so square root of 1 is 1. Now negative 2 plus 3 is a 1, so I just got a 1. Now again, they're saying y smaller than all of this, so 1, because you found 1. So is the y less than 1? Yes. So negative 3, negative 2 is part of the solution. Now try the last one on your own and it should be a no. But check on your own. If you have questions, let me know.